Next, we're going to be looking at the multimodal association areas. Now, a lot of cortices and these association areas that we've been looking at thus far, they've been linked to either a motor or somatosensory area. We've kind of separated them that way, motor or sensory. Well, there's association areas that we haven't quite yet talked about, but they're not as easily linked to one or the other. Now, the reason for this complexity is these multimodal association areas are going to receive multiple inputs from multiple senses, and they send outputs to multiple areas. So they're just more complicated. So that's why we're looking at them second. So let's look at some of the multimodal association areas. So first, just to review, they receive inputs from multiple sensory areas. They send outputs to multiple areas, including the premotor cortex. And in general, they're going to have this pathway. A sensory receptor sends a sensory signal via a sensory neuron to the appropriate sensory cortex. That sensory cortex sends that information to a sensory association cortex, which then sends that information to a multimodal association cortex. It's the multimodal association cortex that then sends that information to the premotor cortex, and then later to a motor cortex that sends out that information to the body. So this allows us to give meaning to information received, to store it as a memory, to compare it to previous experiences, and decide on an action to take. We're not just functioning on raw data, basic information. We are able to put information together, create a kind of full view of how to respond. So that type of decision making is related to the premotor cortex, but that decision making that is multifunctional and multifaceted is possible because of the multimodal association cortices. So there's three broadly divided parts for the multimodal association areas. There's the anterior association area, which is mostly your frontal lobe and that kind of first part of it called the prefrontal cortex. There's a posterior association area and a limbic association area. Your prefrontal cortex of the anterior or kind of front association area, definitely the most complicated cortical region. We believe this is kind of where your personality comes from. There's language areas and a general common interpretation area in the posterior association area. The language areas are responsible for comprehension and articulation, whereas the general common interpretation area receives inputs from all the sensory areas and integrates them into a single thought. Then there's a visceral association area, which is going to give us consciousness about abdominal sensation. So let's go look at the prefrontal cortex. It's the main part of the anterior association area, located on the anterior portion of the frontal lobe. It's involved with your personality, but that means it's involved with intellect and complex learning abilities, cognition, recall, involves some memory and some emotion. And it's absolutely necessary for judgment, reasoning, persistence, and conscience. And it's very closely linked to the limbic system, which we consider your emotional part of your brain. So here you can see the prefrontal cortex in different areas kind of labeled, like those that help with working memory for spatial tasks, the area for executive kind of task management information, working memory, where it's stored, and what we use for object recall tasks, and the area we allow or utilize to help us with solving complex multitask problems. That's kind of on the very anterior tip of the prefrontal cortex. So let's look at a curious case. This is the case of Phineas T. Gage, and he's an individual who kind of gave us some early information about maybe what is that frontal cortex doing for us. Because a lot of the early evidence for the role of the prefrontal cortex, especially in personality, came from this case. Now, Phineas T. Gage was a foreman on a railroad construction area in the middle of the 19th century. He was reported to be reliable, well-organized, and hardworking, which is why he was foreman. And he was tamping in an explosive in a hole that was drilled into rock, and he was doing so with a 13-pound, 3.5-foot long iron bar. And while he was doing that, the charge unexpectedly exploded, and he was packing in the explosive charge, and it exploded and went through his head. So that tapping rod blew out of the hole, went through the front of his head, and it destroyed large portions of his prefrontal cortex. But even though all of his workers were kind of around him, looking at him and what happened, expecting him not to survive his injuries, they did take him to the doctor, and within about 2 weeks, he was up and recovering. And it only took a little while, but they did note as he recovered, his personality had changed. His coworkers started to report the common phrase, Gage was not Gage. He became unreliable, his actions were more impulsive, and he seemed to have little regard for the consequences of his actions. He is reported to have become an alcoholic and a drifter, but he kind of drops off the written record much too soon, really, after his accident. So from this case, we know that the prefrontal cortex receives massive inputs from the sensory association cortices, both somatosensory, visual, auditory, and so it's an important area for higher order cognitive abilities. It's involved in attentional processing, planning, rule learning, and memory. So in 1994, studies were kind of reinvented to look at this case of Phineas T. Gage. So researchers utilized neuroimaging techniques to reconstruct his skull and determine the exact placement of the injury. And their findings actually indicate that he suffered injuries to both the left and right prefrontal cortices, which would result, now that we know more information, we know would result in problems with emotional processing and rational decision making, which explains his coworkers saying Gage was not Gage and that he changed his personality. It was all because of that damage to his prefrontal cortex. We can also look at the posterior association area, which is a really large region in the temporal, parietal, and occipital lobes. It plays roles in things like recognizing patterns, recognizing faces, localizing us in space, kind of letting us know where we are, knowing if our elbows are bent or our knees are bent. And so it's also involved in understanding written and spoken language, so it helps us with reading. It helps us understand if someone looks tense, or if someone's relaxed, or if someone's excited when they're moving their hands around and talking fast. So it's helpful for different parts of language. Wernicke's area, where it's involved in sounding out unfamiliar words, is a sensory area, whereas Broca's area would be a motor area. So make sure to differentiate those two. Both are language areas of the posterior association area. Broca's area is kind of right on that divide between anterior and posterior association area, but it is a true motor speech area that allows for speech preparation and production. We also have the lateral prefrontal cortex, which helps with language comprehension, word analysis, and the lateral and ventral temporal lobe, which has a little bit with coordinating auditory and visual aspects of language, so it works well with Wernicke's area. There is also a general common interpretation area that's really ill-defined. It's more in the posterior association area, kind of in the temporal, parietal, occipital lobes, usually only on one hemisphere, again, usually the left, and it integrates incoming signals into a single thought. So it's involved in a lot of spatial relationship processing. All right, next we're going to be looking at that limbic association area. It includes structures like the cingulate gyrus, parahippocampal gyrus, that sits near that parahippocampal sulcus, and the hippocampus. So these big words, but essentially it's your emotional brain. Your limbic system is going to be responsible for providing emotional impact that makes a scene important to us. It gives us a sense of danger if you were to spill, say, hydrochloric acid on your legs. And then parts of this association area are also going to function in memory, like the hippocampus, that would establish memories and allow you to remember this incident or this kind of sense of danger. Now, the limbic association area is located on the anterior ventral portion of the temporal lobe. So it's near the parahippocampal gyrus, and it's going to link emotion with many sensory inputs, and it's important in learning and memory. It's really the area that takes inputs from the emotional brain, called the limbic system, inputs from the olfactory bulbs and tracts, and inputs from the hippocampus and other structures that function in memory, and even stuff we've learned that is stored in the prefrontal cortex, and just puts it all together. So we can have emotion about conscious thought. Here you can see highlighted areas in the central area. This makes up parts of the cerebrum and parts of the diencephalon. And these are structures of the limbic system or emotional brain that communicate with the limbic association area. Now, before we move on, let's do some review